What is up, guys? This video is about precision and recall in computer vision. Precision and recall are actually quite famous when it comes to object classification and as a result also object detection in computer vision. I'm sure all of you working in computer vision or aspiring to work in computer vision have heard of these two terms. But the problem is there aren't many example based description of precision and recall, and most of us end up just looking at the equations and trying to memorize those equations. Instead of that, in this video we will try to understand what precision and recall, these terms, are based on examples. We will show you the equations, but an example based intuition is much better to cement these ideas in you. So let's get started. These are the two equations you've seen for precision and recall in computer vision. Suppose you have a computer vision model that classifies different images and tells you if, let's say, you have a cat in the image or not. In that case, you have the following four values. True positive means that the image has a cat and the model says you have a cat. True negative means the image does not have a cat and the model says there is no cat. False positive means the image does not have the cat, but the model says there is a cat. And false negative, of course, means that the image has a cat and the model says there is no cat. Based on these equations, you can memorize what precision and recall are. But that is not the best way to go about it. So let's look at two examples to understand what precision and recall are. First example, that will tell you what precision is. Let's say you have 100 images where you either have a red ball or a green ball. A red ball is something you actually want to throw away, and a green ball is something you want to store. In this case, let's say you have a computer vision model that looks at the image and tells you if you have a red ball or not. But the main task in this image is to make sure you don't throw away green balls. If the model detects a red ball, you want to throw it away or throw the image away, so to speak. But in the actual task, you will throw the red ball away based on the image. But you want to minimize wastage. It means that you are okay if a red ball is not thrown away, but you are not okay with the idea that a green ball is thrown away because no wastage. This is a case where you want to maximize something called precision, or in a more intuitive term, you want to minimize false positives. And this is the equation for it. If you minimize false positive, your precision will increase. So you don't want to throw away green balls. You are okay with having some red balls considered as green balls. Here your true positives are going to be red balls that are considered red by the model, and false positives are going to be green balls that are considered red. And as I said, you want to minimize false positives. So in an ideal case, you do not want any green ball to be considered a red ball. The model again is detecting whether it sees a red ball in the image or not. So this is binary classification for the model. So this example is about precision. If you understand this example properly or any other example which is on similar lines, you don't really need to remember these equations. All you need to remember is that you don't want to waste green balls. Talking about recall. Let's say this example is changed slightly where your task is to find red balls like before, but you want to make sure that all red balls are found because they are dangerous. They are, let's say, bombs. So you want to make sure that these red balls are found in the image, and you are okay if a green ball is considered a red ball because that will not lead to any catastrophic case. But if a red ball is not considered a red ball, then it is a bomb. So things are going to explode. In that case, what do you want to do? You actually want to minimize false negatives. In precision, you wanted to minimize false positives. In recall, you are actually minimizing false negatives. It means that you want to make sure that if there is a red ball in the image, it will be considered a red ball. There should not be a case where a red ball is not considered a red ball. And this is the equation for recall. What are we doing here? As I said before, we want to minimize false negatives. And that's all there is. So that is recall. If you understand this example, you again don't need to remember the equation. All you want to do is minimize the cases where a red ball is not considered a red ball, and hence you want to minimize false negatives. So this was precision and recall using examples, and this was a case of binary classification where your classification model was detecting if there was a red ball in the image or not. But what about multi-class classification? Well, let's say you have a case where you have yellow, red, green, blue balls and so on and so forth. You will have precision and recall for each class individually. So instead of just one precision and recall, you will have multiple precision and recall. In our example before, although we had two colors, green and red, we only focused on red. So if there is no red ball, we are not talking about green ball at all. So I just wanted to start with the idea of binary classification using red ball or no red ball. But with multiple classes, 2 or more, you will have multiple precision and recall values for each class. But otherwise, the idea still remains the same. Now, how do you measure the performance of your model based on precision and recall? Because these are two different values, right? We use something called F1 score where we combine the values of precision and recall. In an ideal system, both precision and recall should be 1. But usually in any real application, you have a balance between precision and recall. You would never get precision as 1 and recall as 1. So there is always a balance, and you can choose what you want to focus on more. If, like in our previous example, you wanted to make sure there is no wastage where red balls are thrown away, you will want to have a higher value of precision. But on the other hand, if you want to make sure that red balls are thrown away because they are dangerous, then you will focus more on recall. And you have so many real world examples when you start working on these problems for real world applications. These were just dummy examples, but I hope this drives the message home as to why precision and recall are important, what their ideas are, not just based on these drab equations but based on examples, and how they are used. I hope this video was useful. I will see you in the next video. Bye bye.